Hello, good day. In this virtual class, we'll be looking at these questions uh, basically on the set theory. So use the information to answer the question. Given the universal set is a set of um, numbers or set of positive integers between 1 and 20. Okay. The subset A, 1, 2, 4, 5, 6, 9, 11, and 13. Okay, all this one, they are also members. Okay, they are all obtained from the universal set. Then the set B has element 2, 4, 6, 8, 10, 11, 12, 14, and 16. And the subset C also has the element 1, 2, 4, 6, 5, and 16. You see, 1 list all the elements of the universal set, then represent the information in a Venn diagram. Then find A union B union C complement. Then A intersection B intersection C. Then A intersection B minus C. Now solution to answer the first question is quite straightforward. Say you should list all the elements. Remember, element in set also means members. Okay, so it means what are those things that are contained in the universal set? They are set of positive integers between 1 and 20. So please let's look at this. So here, if you list them, this is 19. Sorry about that. This is 19. Okay. So from 1 to 19, that's the first question. And the second question say which should represent the information in a Venn diagram. How do we go about that? First thing to do is to look at all the subset A, B, C. To answer this question is to look at all the subset. What are those elements that are common in the subset A, B, and C? Let's look at this. We have 2 here. We have 2. We have 2. So 2 is one of those things. That is, we have to include it where the 3 subsets are main. So we have 2. Let's look at it. We have a 4, 4, and 4. Okay, they are present in the 3 subsets, so we indicate 4 here as well. Let's look at 5 here. There's no 5 here. Okay, so let's look at 6. We have 6. We have 6 here. Okay, so we indicate this here. So these are A intersection B intersection C, those elements that are present in A, B, in the subset A, B, and C. So since we have done with that, let's look at our A intersection B. Or are there some elements that are in A and also in B? Let's look at it. Okay, they are only in A and B alone. Okay, is 11. Okay, the other elements, so we indicate that here. Okay, now let's look at, are there some element in B and they are also present in C? Let's look at B intersection C. What are those elements that are in B and they are also in C? Okay, we could see it only 16. Okay, 16. So we indicate it here as B intersection C. Okay, now let's move on. Let's look at, are there some element in A and they are also present in C? Like A intersection C. Okay, yes, 1. Okay, so we have a 1 here. You can 1 here. Also have 1 is C. So in that portion where A intersection C, so we indicate 1 here. So once we are done with this, we are through with that aspect. So now let's go to A and see all those elements that are remaining that are we didn't touch here, that is not touched. Those elements that are not sure touch is 5, 9, and 13. So we come here on this portion, we put 5, okay, 9, and 13. Okay, so let's look at the subsets B. What are those elements that we didn't touch at all there? The elements are in B. We have 8, 10. Okay, 10. 12 and 14. So we list all those elements that are in B that we didn't touch. Okay, see, let's move on. Let's go to C. The element that are in C that we did not touch is only 5. So we indicate 5 here. So this is 5. So now we also know that this subset A, B, and C are obtained from the universal set. So we are going to look at those elements that are not in A, B, and C, but they are present in the universal set. So let's identify them. Here, 7 is one of them. Okay, 7 is one of them. So we're going to write those one outside. After 7, we have a 7. Okay, we have a 7. Look at it. Have um, okay, okay, so 14 is here, so 15. The next one is 17. We also have 18. They are not part of those subset A, B, C. Then 19 and what? Eventually we have a 20. So these are the elements that are here. They are here. Okay, so also 3 is also part of it. 3 is also part of it. So we also indicate 3 here. So 3 is also part of it. So we also indicate 3 here. So every other elements though that are not present in the subset ABC, they are indicated in the rectangle. So now we are able to do that. So that's we are able to represent the information in a Venn diagram. Okay. Now what next is this? They say we should find A union B union C complement. Now what do you understand by the complement of a set? Now the complement of a set is simply a set, or let's put it this way, there are some members that are in the universal set here. They are here, but they are not present in A union B union C. Here, A union B union C simply means all the elements present in A, B, and C. So those ones are the elements that we have in all this one, A, B, and C. So now when you are referring to A union B union C complement, simply means that there are some elements that are in the universal set, but they are not present in the other 3 subset A, B, and C. And simply you can easily identify that as those elements that are written outside these circles. Okay, so those ones that are present in the rectangle. So to indicate that, it's just simply we have a 3, 7, 15, 17, 18, 19, 20. So these are A union B union C complement. So they are those elements that are not present in the subset A, B, and C, but actually they are present in the universal set. So let's find A intersection B intersection C. The intersection of set simply means all those elements that are in A, B, and C. And from here you can easily get them here. So we have a 2, 4, 6. So A intersection B, the element are 2, 4, and what? And 6. So these are what? A intersection B intersection C. Now let's look at the very last question. We say that A intersection B minus C. Now what are the elements? Okay, what are the elements of A intersection B? Okay, now what does it mean by A intersection B? Those elements that are present in A and they are also in B. So we can just get it here. Only element that are present in A and B is 11. Okay, so the A intersection B, that portion is just 11. Now let's look at the meaning of this sign, difference. So the difference uh, of two sets simply means those elements that are present in A intersection B, but they are not in the subset C. So you know we have the subset, all the elements or the members of C are, look, let's go back to it. Okay, members of C are 1, 2, 1, 2, 4, 6, 5, and 11. Then A intersection B, the element is just 1. So the A intersection B minus C simply means that there are some elements. What are those elements in A intersection B? But they are not in C. So it's simply the same thing as 11. Okay, so A intersection B minus C, intersection B minus C is simply the element here is simply just 11. Okay, so the meaning or the difference of two sets simply means those members that are in A intersection B, but they are not in C, so which is just 11. So please, if you find this video very useful, please help me subscribe and also share this on your social media platform. See you in my next virtual class.